This is stardust, and so is this, and this, and this. Okay, but that might leave you wondering, how is stardust made? Well, I'm glad you asked. Let's dive into the world of stellar nucleosynthesis. Let's break down the word. Stellar means related to the stars, nucleo is a prefix meaning nucleus, and in this case of the atom, and synthesis means to create. So basically this means creating new nuclei in stars. How stellar is that? Well, do you want to see the stars? Let's look through my telescope. What you see now is a young star with a core full of hydrogen that was made during the Big Bang. When two hydrogen isotopes smash together fast enough to overcome Coulomb's forces, we'll have a helium isotope plus a lot of energy. You can keep smashing stuff to make bigger and bigger elements, and by doing so, the star gets energy to keep going. That's star-tastic! Let's go back to our friend hydrogen here. Both of these nuclei are hydrogen, but they look kind of different. When a nuclei has the same amount of protons but different atomic masses, that's called an isotope. This is hydrogen 2 and this is hydrogen 3. So, has the periodic table really been lying to you? Not really. Another formulation of the periodic table is the chart of nuclides. This shows all the isotopes and their properties. Once the star runs out of hydrogen, it fuses helium and so forth to make heavier elements. Stellar fusion can only go up to iron because to make elements past that requires a greater amount of energy to fuse them than the star gets out. But stars are lazy. But Shruthi, you may ask, how are all the elements heavier than iron made? That's a great question. Going back to the chart of nuclides, we see all these colorful isotopes deviating from the band of stability. Different processes form these isotopes. The S process captures neutrons very, very slowly because there aren't many neutrons to go around. The resulting nucleus is unstable and will undergo beta- decay, which means the neutron becomes a proton and releases an electron and an antineutrino. Surprisingly, the isotope is a new element one atomic number higher. Another process, the R process, happens when a neutron is captured before the nucleus has a chance to decay back to stability. Nuclear astrophysicists are learning more about how cool new nuclei are formed in different types of stellar explosions. One really cool one you may have heard of is neutron star mergers and the gravitational waves they let off, which create the lanthanides, including the really strong neodymium magnets in your phone. So the next time your star is struck by the night sky, send a thank you to those stars for burning bright. They made you, after all.